engineering.
Every legal AI product on the market works the same way. You type instructions into a chat interface. One AI model reads your input in a single pass. It generates output. You get what you get. This is not engineering. This is hope. Here is the proof that architecture matters. The same frontier AI model, Claude Opus, analyzed the same 42,000-word M&A agreement. Single prompt, 35 track changes, 0 legal citations. 26 agent pipeline with 6 sequential rounds. 138 track changes, 18 legal citations. A 3.9x improvement with 0 change in model capability. The model did not get smarter. The system around it got engineered. Legal engineering is the practice of designing, building, and deploying AI-powered workflows that automate legal work using multi-agent pipeline architectures. It sits at the intersection of 3 domains: legal practice, software engineering, and AI systems design. It is not prompt engineering if that operates at the wrong level of abstraction. A prompt engineer optimizes one message to one model. A legal engineer designs a system of 20 or 30 coordinated AI calls, each with a specialized role, producing deliverables that meet the standard of care. The defining insight of legal engineering is structural isomorphism. Legal logic and computational logic are not similar. They are not related. They are the same formal structure expressed in different syntax. A date in a contract and a date object in TypeScript are the same thing. A conditional clause and an if statement are the same thing. A list of obligations and an array of strings are the same thing. This is not an analogy. It is what makes the entire discipline possible. Consider the mapping. Effective as of January 1st, 2025 equals new date, January 1st, 2025. 30 calendar days equals the number 30. If the closing conditions have been satisfied, equals true. If applicable, the escrow amount equals an optional number field. Schedule A, list of licensed patents equals an array of strings. Legal documents are structured data written in natural language. AI can parse that structure because the underlying logic is identical to what software systems already process. This discipline serves 4 audiences. Attorneys who want to build the AI systems transforming their profession, not just type questions into chatbots. Software engineers entering the legal vertical who need to understand privilege, standard of care, and regulatory constraints. Legal operations professionals who need to distinguish genuine capability from marketing claims. And students pursuing careers at the intersection of law and technology in a discipline that did not exist 5 years ago and will be indispensable 5 years from now. If you are building legal AI workflows, your programming language is TypeScript, not because it is trendy, because type safety catches errors before they reach clients. A contract analysis system that crashes at 2 a.m. because someone passed a string where a number was expected is not a minor inconvenience. It is a malpractice risk. TypeScript's compiler catches that mistake before the code ever runs. Strict mode is non-negotiable. TypeScript interfaces define the shape of legal data. A contract party has a name, a role restricted to customer or vendor or buyer or seller, a jurisdiction, and an address. An analysis result has a clause ID, a risk level restricted to low, medium, high, or critical, a recommendation and optional citation and dollar exposure fields. Union types ensure no misspelled string ever silently routes a contract to the wrong analyzer. The compiler enforces what good judgment should. Every legal engineering pipeline is powered by Claude, accessed through an HTTP API. You send a structured request with your prompt and parameters. You receive structured text back. The model processes tokens, fragments roughly 3/4 of a word each. A 200-page M&A agreement consumes about 80 to 120,000 tokens, fitting within a single context window. Token count determines both cost and capacity. A single Claude API call analyzing a complex contract can take 60 to 120 seconds. If your pipeline makes that call synchronously, the HTTP connection times out. Production legal pipelines solve this with streaming. Instead of waiting for the full response, the API sends tokens as they are generated over a persistent connection. Your code collects chunks into a complete response. The connection stays alive because data flows continuously. This is why legal pipelines never block. Every API call has a cost. Input tokens cost $15 per million. Output tokens cost $75 per million. A single contract analysis consuming 100,000 input tokens and 20,000 output tokens costs approximately $3. A 26-agent pipeline will consume more total tokens than a single call because context overlaps. But 26 specialized agents consistently outperform a single monolithic prompt. The quality delta justifies the cost premium. This is a trade-off every legal engineer must understand. When a pipeline stage needs structured data, a risk score, a clause classification, a routing decision, you need guaranteed JSON. Structured outputs solve this by providing a JSON schema directly to the API. The model is constrained to produce valid JSON matching that exact schema. No rejects parsing, no repair functions, no silent failures where a broken parser falls back to approving every clause. Schema in, valid JSON out, every time. Word documents are not what they appear to be. A docx file is a zip archive containing XML files. The actual document text lives in Word. Our document.xml as a tree of paragraphs, runs, and text nodes. Track changes, the red lines attorneys rely on, are specific XML elements. W, del nodes, mark deleted text. W, ins nodes, mark inserted text, each tagged with an author and timestamp. To produce real red lines, you perform surgery on this XML tree. This is not optional. Attorneys will not accept plain text suggestions. The infrastructure layer connects everything. Express servers expose pipeline endpoints. React dashboards render results. Server-sent events stream real-time progress as each pipeline stage completes. MongoDB stores analysis history. The architecture follows a clean separation. The back-end orchestrates AI calls and OOXML manipulation. The front-end displays progress and deliverables, and SSE bridges them in real time. When a user uploads a contract, they see each analyzer light up as it completes, not a loading spinner and a prayer. Every legal operation, without exception, decomposes into the same four-part pattern. Trigger, input, requirements, output. TIRO. A contract needs drafting. That is a trigger. The playbook and party positions are the input. The drafting rules, defined terms, validations, and transformations are the requirements. The finished agreement is the output. This pattern applies to every workflow in this book, every pipeline stage, and every AI call. Master TIRO, and you can decompose any legal operation into buildable components. The trigger is what initiates the operation. A new contract uploaded for review, a compliance deadline approaching, a client requesting a research memo, an M&A data room opened for due diligence. The trigger defines the event boundary, what happened that requires action. In a pipeline, the trigger is the API endpoint that receives the request and launches the orchestrator. Input is the data the operation consumes. For contract drafting, the playbook with your party's positions, the counterparty's known preferences, the contract vertical, and any prior drafts. For redlining, the counterparty's contract plus your playbook. For litigation support, the document collection plus the issue tags plus the privilege criteria. The input determines what the AI has to work with. Incomplete input produces incomplete output. This is where garbage in, garbage out becomes a design constraint. Requirements are where legal engineering diverges from simple AI chat. The R in TIRO expands into 4 subcomponents: arbitration, the rules governing conflicts between positions; definitions, the precise meaning of every term; validations, the checks that catch errors before they propagate; and transformations, the operations that convert input into output format. A playbook position that says liability cap at 12 months of fees is a definition. Checking that the cap does not contradict the indemnification clause is a validation. Converting the position into contract language is a transformation. Output is the deliverable, a drafted agreement in OOXML format, a redlined contract with real OOXML track changes, a risk score matrix, a compliance determination with cited regulations, a research memo with verified authorities. The output is what the client or attorney receives. It must meet the standard of care for legal work product, not the standard for AI summaries, not the standard for chat responses. The standard that a competent attorney would apply if they had done the work manually. TIRO is not just a decomposition tool. It is a design language. When you look at any contract clause through the TIRO lens, the engineering solution becomes obvious. Take a termination for convenience clause. The trigger is notice from either party. The input is the notice period, and any cure provisions, the requirements include validating that the notice period matches the governing law minimum and transforming the clause into structured data, and the output is the parsed termination provision with its conditions mapped to enforceable Boolean logic. Same clause, same logic, different syntax. Why does a single AI call fail to produce partner-level work? Because one call cannot simultaneously be the drafter, the reviewer, the specialist, and the quality controller. A first-year associate working alone produces adequate output. A deal team with specialists in IP, tax, employment, and regulatory produces excellent output. Multi-pass pipeline architecture replicates the deal team, not the solo associate. The fundamental building block is the diplomat pattern. Every pipeline stage consists of 2 paired agents, a prompter and an executor. The prompter frames the task. It analyzes context, identifies priorities, and constructs precise instructions. The executor performs the task using those instructions. This separation ensures the executor receives optimized input, not raw, unstructured context. The prompter is the senior partner who briefs. The executor is the associate who delivers. The back autocrat orchestrates the entire pipeline. It chains diplomat pairs in sequence, feeds the output of one stage into the input of the next, tracks metrics at every step, and handles failures gracefully. When Stage 3 needs the output of Stages 1 and 2, the back autocrat ensures the dependency chain is respected. When Stages 4A and 4B are independent, the back autocrat launches them in parallel. It is the pipeline's nervous system. Multipass catches what single pass misses. When an AI drafter generates a contract in a single call, it must hold the entire playbook, every defined term, every cross-reference, and every jurisdiction-specific requirement in working memory simultaneously. Errors cascade because there is no review. Multipass breaks the task into stages. The drafter drafts. Specialist editors review their domain, IP terms, indemnification caps, data protection obligations. A final author synthesizes all edits into a coherent document. Each pass narrows the error surface. The empirical evidence is clear. In our first controlled experiment, we ran 3 pipeline variations against the same contracts using the same model. Single author, one AI call produces the draft. Author, then enhancer, draft, then review enhance. Drafter editors. Author, draft. Then 10 parallel specialist editors, then a final synthesis author. The third variation consistently outscored the first by 4 to 8 points on a 100-point rubric. Multipass measurably improves quality. The diminishing returns curve tells you where to stop adding passes. Parallelization is where legal engineering achieves scale. When your pipeline needs 16 independent analyzers to examine the same contract, an indemnification specialist, a data protection specialist, a payment terms specialist, a limitation of liability specialist, running them sequentially means the wall clock time multiplies by 16. Running them in parallel with promise all settled means they all complete in the time of the slowest single analyzer. 16 minutes becomes 90 seconds. Promise. All settled is the correct parallel execution primitive, not promise all. Promise all fails entirely if any single promise rejects. One broken analyzer out of 16 kills all 16 results. Promise. All settled always returns all results, marking each as fulfilled or rejected. In production, you want 15 good analyses plus 1 error log, not 0 analyses plus a crash. Fan out to all specialists simultaneously. Fan in to collect results. Log failures. Move forward. When 158 specialized agents need concurrent API access, rate limiting becomes a design constraint. You cannot fire all 158 calls simultaneously without hitting API rate limits. A rate limiter queue manages throughput. It maintains a pool of available slots, launches calls as slots open, and ensures you never exceed the API's requests per minute ceiling. The pipeline runs at maximum sustainable throughput without triggering throttling. This is infrastructure that makes swarm architecture practical at production scale. Attorneys will not accept plain text suggestions. They need real track changes in real Word documents, the same red lines they have been reviewing for decades. This means performing surgery on OOXML, the XML-based format inside every docx file. You unzip the document, parse the XML tree, locate the target paragraph, and run, insert wwdel and wins nodes with proper revision IDs, author tags, and timestamps, then repackage the zip. The output opens in Microsoft Word with genuine tracked changes. Accept or reject, just like a human attorney produced them. The anatomy of a tracked change in OOXML is precise. A deletion wraps the original text in a wdel element with attributes, revision ID, author name, and date. An insertion adds a wins element with the replacement text and the same metadata. Both sit within the paragraph's run structure. The revision ID must be unique and sequential. The author string appears in Word's revision pane. Get the XML structure wrong by one attribute, and Word silently ignores the change or, worse, corrupts the document. Precision matters at the byte level. Server-sent events bridge the back-end pipeline to the front-end dashboard in real time. When a user uploads a contract, the pipeline launches, and each stage emits progress events. Round 1, complete, vertical detected, 16 analyzers running, analyzer 7 finished, red line generation starting. The front end renders each event as it arrives. The user watches the pipeline work stage by stage in real time. No loading spinners, no waiting in the dark. Transparency builds trust in the system's output. The API layer follows a clean pattern. An express endpoint receives the upload, contract file, playbook, party context. It launches the back autocrat, which orchestrates the full pipeline. Each stage streams SSE events to the client. When the pipeline completes, the final artifacts, the redline docx, the risk matrix, the negotiation email, are stored and made available for download. The endpoint handles authentication, credit billing, error recovery, and artifact storage. This is not a demo. This is production infrastructure, Attorney-client privilege is not a feature request. It is a constitutional protection that constrains your entire architecture. Every document processed by your pipeline may be protected by privilege. If your system stores that document on a third-party server without proper controls, privilege may be waived. Waived privilege cannot be restored. The attorney-client relationship, the litigation strategy, the settlement position, all exposed. This is why data architecture is a legal engineering concern, not just a DevOps concern. The security requirements flow directly from privilege. Own your infrastructure. Do not send client documents through third-party processing pipelines you do not control. Encrypt at rest and in transit. Implement access controls that restrict document access to authorized users. Maintain audit logs that demonstrate who accessed what and when. Classify data by sensitivity level. These are not optional hardening measures. They are the minimum requirements for a system that processes privileged legal materials. Build them in from day one or rebuild from scratch later. Contract drafting is the first applied workflow. The input is a playbook, a structured document containing your party's positions on every material term. Liability cap at 12 months of fees. Governing law, New York. Indemnification mutual with carve-outs for IP infringement and data breach. The pipeline converts these positions into contract language through a multi-pass architecture where each pass adds precision and consistency. The drafting pipeline operates in 3 stages. An author agent generates the initial draft from the playbook, covering all material terms in the correct structure. Then, parallel specialist editor agents, as many as the contract demands, review their specific domains. An IP editor checks licensing language. An indemnification editor validates liability frameworks. A definitions editor ensures every defined term is internally consistent. Finally, a synthesis author incorporates all editorial feedback into a polished, coherent agreement. One draft, many specialists, one final product. Contract redlining is where legal engineering delivers its most dramatic value. You receive a counterparty's contract. Your pipeline deploys 158 parallel AI analyzers, each specialized in a different aspect of contract risk. They attack the document simultaneously, identifying provisions that expose your client to liability, missing protections, ambiguous language, and unfavorable terms. The output is not a summary. It is a fully redlined Word document with real OOXML track changes, deletions, and insertions that the attorney can accept or reject in Microsoft Word. The redlining pipeline produces 3 deliverables. First, the redlined DOCX with tracked changes, every recommended edit precisely positioned in the document's XML structure. Second, a negotiation email drafted in the attorney's voice, presenting the key positions and their rationale to the counterparty. Third, a risk assessment matrix scoring every identified issue by severity and recommending prioritized negotiation strategy. This is partner-level output. A junior attorney doing this manually would take 40 hours. The pipeline delivers in 30 minutes. Contract analytics transforms individual contract analysis into portfolio-level intelligence. Instead of reviewing one contract at a time, the analytics workflow processes entire contract portfolios, extracting terms, scoring risks, identifying patterns across hundreds of agreements. What percentage of your vendor contracts have unlimited liability exposure? Which contracts expire in the next 90 days without auto-renewal? Where are your indemnification gaps? These are portfolio management questions that no human team can answer across 1,000 contracts. The analytics pipeline follows a 3-stage architecture. First, a schema-aware extractor identifies and captures every material term from each contract: party names, dates, financial terms, liability provisions, renewal conditions. Second, A risk scoring engine weights each extracted term against configurable criteria. A missing limitation of liability in a high-value contract scores critical. An unfavorable governing law in a low-value agreement scores moderate. Third, a dashboard visualization layer presents the portfolio data. Heat maps, trend lines, expiration calendars, and drill-down capability to the source clause. Regulated communications review is the fourth workflow. Every financial institution, healthcare provider, and publicly traded company generates communications subject to regulatory oversight. Marketing materials, client correspondence, social media posts, investor updates, each must comply with jurisdiction-specific rules. FINRA governs broker-dealer communications. The SEC governs investment advisor advertising. HIPAA governs patient health information. The FTC governs consumer-facing claims. A single non-compliant email can trigger enforcement action. The compliance pipeline applies a multi-framework overlay. The same communication is analyzed against every applicable regulatory framework simultaneously. Parallel compliance agents, one per framework, scan for prohibited language, missing disclosures, unsupported claims, and required disclaimers. A synthesis agent maps the findings into a severity-tiered matrix, critical violations that block publication, material issues requiring revision, and minor suggestions for improvement. The output is a compliance determination, not a vague warning. Pass, fail, or revise, with specific citations to the violated regulation. Third-party risk assessment is the fifth workflow. Every organization depends on vendors, and every vendor introduces risk. A cloud provider stores your data. A payment processor handles your transactions. A staffing agency accesses your facilities. Third-party risk assessment evaluates each vendor against a structured rubric: data handling practices, security certifications, financial stability, regulatory compliance history, and contractual protections. The pipeline processes vendor questionnaires, public filings, and contract terms to produce a risk profile. Not all vendors warrant the same scrutiny. A critical vendor, one whose failure would halt your operations, requires deep assessment, security audit review, penetration testing evidence, business continuity plans, insurance verification. An important vendor warrants moderate assessment, questionnaire review plus contract analysis. A standard vendor needs baseline screening, automated questionnaire scoring, and contract term extraction. The pipeline routes each vendor through the appropriate assessment tier based on criticality classification, applying resources proportional to risk. Document triage is the sixth workflow, and it solves the inbox problem. A legal department receives hundreds of documents weekly: contracts for review, regulatory filings, court orders, internal memos, vendor questionnaires, compliance reports. Each requires different handling, different teams, different urgency, different workflows. Manual triage is slow and inconsistent. AI-powered triage classifies each document by type, extracts key metadata, assigns urgency, and routes to the appropriate workflow. All within seconds of arrival. Our R&D experiments proved something surprising about triage. A single general-purpose classifier scored 52 out of 100 on a comprehensive triage rubric. 6 specialist agents, a contract identifier, a regulatory filing detector, a court document analyzer, a compliance report screener, a correspondence classifier, and a priority assessor, fed into a synthesis agent, scored 96 out of 100, a 44-point improvement. The specialist architecture did not just improve accuracy. It produced actionable intelligence that the single-pass approach could not generate at all. Obligation tracking is the seventh workflow. Every contract creates obligations, deadlines, deliverables, reporting requirements, renewal windows, termination notice periods. Miss a deadline, and you face breach. Miss a renewal window, and an unfavorable contract auto-renews for another year. Obligation tracking extracts every commitment from every contract, maps dependencies between obligations, generates calendar entries, and triggers alerts before deadlines arrive. The pipeline turns passive contracts into active compliance monitoring. The obligation pipeline follows a four-stage architecture. First, an extraction agent identifies and classifies every obligation in the contract using a standard taxonomy: payment obligations, performance obligations, reporting obligations, compliance obligations, and notice obligations. Second, a dependency mapping agent identifies relationships between obligations. This payment depends on that deliverable. This notice must precede that termination. Third, an alert cascade engine generates escalating notifications. 30 days out, 14 days, 7 days, 1 day. Fourth, calendar integration pushes every deadline into the team's calendar system. M&A due diligence is the eighth workflow, and it operates at a scale that overwhelms human teams. An acquisition target's data room may contain thousands of documents, contracts, corporate filings, employment agreements, IP registrations, regulatory correspondence, financial statements, litigation records. The due diligence team must identify every material risk, every change of control trigger, every consent requirement, and every liability exposure across that entire collection. Manually, this takes weeks. With an engineered pipeline, the initial triage and risk mapping completes in hours. The M&A pipeline operates in 4 stages. First, data room triage classifies every document by type, relevance, and priority. Second, change of control analysis scans every contract for provisions triggered by the acquisition: consent requirements, acceleration clauses, termination rights, assignment restrictions. Third, liability discovery identifies pending litigation, regulatory investigations, indemnification obligations, and warranty exposure across the entire collection. Fourth, a risk matrix synthesizes all findings into a prioritized due diligence report that the deal team can act on immediately. Litigation support is the 9th workflow. When litigation arises, the legal team faces document review at massive scale. E-discovery produces document collections measured in terabytes. Each document must be reviewed for relevance, privilege, and issue coding. Privilege review alone, determining whether a document is protected by attorney-client privilege, requires examining sender, recipient, subject matter, and context. A single mistake, producing a privileged document, can waive privilege over the entire subject matter. The stakes are existential. The privilege screening pipeline uses multi-agent review with a decision tree architecture. A first-pass agent identifies potentially privileged documents based on sender and recipient patterns, communications involving attorneys, legal departments, or outside counsel. A second-pass agent analyzes subject matter. Is this a request for legal advice, a litigation strategy discussion, a settlement negotiation? A third-pass agent evaluates exceptions. Has the privilege been waived by disclosure to third parties? The output is a privilege determination with cited criteria, defensible in court if challenged. Legal research is the 10th and final workflow. When an attorney needs to construct a legal argument, they must identify relevant authorities, statutes, regulations, case law, and synthesize them into a coherent memo. The challenge is not finding cases. The challenge is finding the right cases, verifying they have not been overruled, and assembling them into a persuasive narrative that supports a specific position. AI-powered research must produce verified authorities with accurate citations, not hallucinated case names that sound plausible but do not exist. Our legal research R&D experiment tested 3 architectures. A single researcher scored 73 out of 100, impressively capable for one AI call. A prompter plus 5 parallel researchers without synthesis scored 60.5, worse than single pass, because parallelization without coordination produces redundant, disorganized output. A prompter plus 5 parallel researchers plus a synthesis agent scored 77, the highest of all 3. The lesson: parallelization alone is not enough. You need the synthesis step to transform parallel fragments into a coherent, usable deliverable. Behind every workflow chapter in this book is a research program. Taylor Legal Engineering runs controlled experiments comparing pipeline architectures, the same input, the same scoring rubric, multiple pipeline variations. Every experiment produces measurable data: quality scores, token costs, latency, accuracy deltas. The results are published, the methodology is transparent, and the findings become curriculum in the TLE Academy. This is not marketing. This is empirical science applied to legal workflow engineering. Look across all 10 workflows and a pattern emerges. Everyone uses TIRO for decomposition. Everyone uses the diplomat pattern for individual stages. Everyone uses parallelization for independent operations. Everyone uses a back autocrat for orchestration. Everyone produces deliverables that meet the standard of care for professional legal work. The workflows are different. Drafting is not triage, is not due diligence, but the engineering foundations are identical. Master the foundations, and you can build any legal workflow. The central thesis of this book is that architecture matters more than model selection. The AI model is not the product. The architecture around the model is the product. A well-architected pipeline around last year's model will outperform a single prompt to next year's model. The industry fixates on which model is best. Legal engineering focuses on how to organize 20 or 30 specialized agents into a system that produces partner-level output. The 3.9x improvement was not a model upgrade. It was an architecture upgrade. Legal engineering is a career, not a hobby, not a side project, not a buzzword, a discipline with its own methodology, its own patterns, its own standard of care. 5 years ago, it did not exist. 5 years from now, every law firm with more than 50 attorneys will either employ legal engineers or lose business to firms that do. Every legal technology vendor will either adopt multi-agent pipeline architecture or produce inferior products. The question is not whether this transition happens. The question is whether you lead it or follow it. The TLE Academy exists to teach exactly what this book covers and to certify that you can build it. 16 interactive modules, from technology essentials through every applied workflow. Hands-on coding exercises graded by AI against rubric criteria. The TLE Certified Legal Engineer Credential. The first professional certification for the discipline of building AI-powered legal workflows. Nobody else can simultaneously practice law, build production AI systems, and teach the methodology. That is why TLE sets the standard. Here is what this book teaches you to build. Not a chatbot. Not a summary tool, not a legal assistant that gives you something close enough. A production system, a system with 26 coordinated AI agents, a system that produces real OOXML track changes, a system that cites real legal authority, a system that meets the standard of care for professional legal work. The gap between adequate and production ready is where real money and real risk live. Legal engineering closes that gap. Now, go build.